Hi, welcome to New Tech YouTube channel. In this video, we are going to study and solve example on node analysis. Let's start. Node analysis is used in network or circuit theory to obtain node voltages using KCL and Ohm's law. See KCL statement. The algebraic sum of all currents entering and leaving a node must be equal to 0. If you are interested to learn more about KCL, I will give you link of the same in the description. Now, see some key terms which are helpful in node analysis. First key term, node, a point at which two or more elements, that is resistors, voltage or current sources, have a common connection. Second key term, branch, a single path in a network composed of one simple element and the node at each end of that element. Let's see node and branch representation using a resistor as an element with two nodes, that is node 1 labeled as A and node 2 labeled as B in a given diagram, with element connecting node A and node B called as branch. Before applying KCL to a given node in node analysis, let's study sign conventions. First sign convention, currents entering into the node consider as a negative, and second sign convention, currents leaving from the node consider as a positive. Let's see node N representation as currents I1, I2 and I4 are entering into the node N as per sign convention consider as a negative currents, and currents I3, I5 and I6 are leaving from the node N as per sign convention consider as a positive currents. We just studied KCL and sign conventions useful for node analysis. Let's study and understand procedure of node analysis. Procedure. Step 1. Identify the total number of nodes. Step 2. Assign the voltage at each node. Step 3. Develop the KCL equation for each node. And step 4. Solve the KCL equations to get the node voltages. Using procedure of node analysis, now solve example using the same example statement. Using node analysis, find node voltages. Let's write given data. Here, assume current IA and current IB as a current sources labels. Therefore, current IA is equal to 5 ampere, resistor R1 is equal to 10 ohm, resistor R2 is equal to 20 ohm, resistor R3 is equal to 30 ohm, and current source IB is equal to 3 ampere. Now find node voltages using following diagram. For solution, refer procedure step by step. Step 1. Given circuit having two active nodes, that is node 1 and node 2, and one datum or inactive or reference node, and we are assuming reference node having voltage at 0 volt, with node 1 is formed by elements as 5 ampere current source, resistor R1 and resistor R2. Similarly, node 2 is formed by elements as 3 ampere current source, resistor R2 and resistor R3. We have just seen the formation of node 1 and node 2 in the given circuit. Procedure step 2. We assigned voltage V1 at node 1 and voltage V2 at node 2, and also marked currents I1 and I2 which are leaving from node 1 through resistor R1 and R2 respectively. Procedure step 3 part A. Here assume voltage V1 at node 1 is at higher potential than the voltage V2 at node 2. With reference to step 2, apply KCL at node 1. We get minus of current source IA plus current I1 plus current I2 is equal to 0, which is represented by equation 1. Using equation 1a, now substitute values of current source IA, resistor R1 and R2 as we get a equation as minus 5 ampere plus V1 upon 10 ohm plus V1 minus V2 upon 20 ohm, which is equal to 0. Separate the denominator of the third term, that is V1 minus V2 upon 20 ohm, and rearrange the equation as V1 upon 10 ohm plus V1 upon 20 ohm minus V2 upon 20 ohm, which is equal to 5 ampere. Simplify and rearrange the terms. We get KVL equation at node 1 as 3V1 minus V2 is equal to 100 volt, which is represented by equation 2. Now let's see procedure with step 3 and part B. Here assume voltage V2 at node 2 is at higher potential than voltage V1 at node 1. With reference to step 2, apply KCL at node 2 as current source IB plus current I2 plus current I3 is equal to 0, which is represented by equation 3, where current source IB is equal to 3 ampere, current I2 is equal to voltage V2 minus voltage V1 upon resistor R2, and current I3 is equal to voltage V2 upon resistor R3. Now substitute values of current source IB, resistor R2 and resistor R3 into equation 3a as current 3a plus voltage V2 minus V1 upon 20 ohm plus voltage V2 upon 30 ohm is equal to 0. Let's separate the denominator of second term, that is V2 minus V1 upon 20 ohm, and rearrange the equation. After denominator separation, equation becomes current source 3a plus voltage V2 upon 20 ohm minus voltage V1 upon 20 ohm plus voltage V2 upon 30 ohm is equal to 0. Combine the voltages V1 and V2 terms as minus V1 upon 20 plus 30 into voltage V2 plus 20 into voltage V2 divided by 600 is equal to minus 3 ampere, which is represented by equation 3b. Now simplify the equation 3b as minus 30 into voltage V1 upon 600 plus 50 into voltage V2 upon 600 is equal to minus 3 ampere. Shift common denominator term to the right side of equal to sign as minus 30 V1 plus 50 V2 is equal to minus 3 ampere into 600. After simplification, we get a equation as minus 3 into voltage V1 plus 5 into voltage V2 is equal to minus 180, which is represented by equation 4. Let's solve KVL equation at node 1 and 2, which are represented by equation 2 and 4 as 3V1 minus V2 is equal to 100 and minus 3V1 plus 5V2 is equal to minus 180. Here equation 2 having coefficients of voltages V1 and V2 are 3 and minus 1, and in equation 4 coefficients of voltage V1 and V2 are minus 3 and 5. Along with equation 2 and equation 4 having constant values as 100 and -180 respectively. Here we are obtaining solution of equation 2 and 4 using determinant method. Determinant D is called as coefficient determinant and represented as determinant D is equal to coefficients of equation 2 as 3 and -1 and coefficients of equation 4 as -3 and 5. Now after solving determinant D, we get a value of D as 12, where determinant dV1 is constructed by replacing coefficients of voltage V1 as 3 and -3 as in determinant D by its constant values as 100 and -180 respectively. Now solve determinant dV1, we get value as 320. Similarly, find determinant dV2 as replacing coefficients of voltage V2 as a -1 and 5 with the determinant D by its constant values as 100 and -180. Now solve determinant dV2, we get a value of dV2 as -240. Now find values of node voltages V1 and V2 using determinant D and determinant dV1 and dV2 as voltage V1 is equal to determinant V1 upon determinant D is equal to 320 upon 12 is equal to 26.67 volt and voltage V2 is equal to determinant dV2 upon determinant D is equal to -240 divided by 12 is equal to -20 volt. We obtained node voltages using determinant method as voltage V1 is equal to 26.667 volt and voltage V2 is equal to -20 volt. Here we verified our results of node voltages using Multisim software had given the same node voltage values of V1 and V2 as 26.667 volt and -20 volt. In this video, we have studied theory and solved example on node analysis. Thanks for watching my YouTube channel. Thank you.